Let's see. A little delay. So
Not live on YouTube yet.
yeah, hello everyone. Welcome to CJUG tonight. So we're gonna be starting momentarily, and it looks like we're having everybody joining from a lot of different places in the U.S. and also outside too. I see somebody from Canada already, and I'm not sure if folks from Europe can join because it's actually quite late there. So, and okay, and then please, everybody, if you have any questions because of the setup here, please type what you need on the YouTube chat channel. So, okay. Maybe currently we have 17 people watching now, I can see. Okay. And maybe you can introduce yourselves. Yeah, great. Yeah, I think David already typed that you are from Denver, and we have Sirisha from Pittsburgh. Hi, Sirisha. Sirisha is from the Pittsburgh JUG, so you know. And also, I think somebody too, right? Another JUG. Niha, you're from New Jersey JUG, I believe. So that's nice to have other JUG members joining from all over the world. Very cool. Let's see. So yeah, so tell us where you're from if you like on chat. So,
is there a way that those of us on the panel can have public chat comments?
Yes.
Because when I switch over to the comments panel, I don't have a text box anymore.
Oh, you don't? Why would it? Okay, well, I need to invest.
Yeah, I'm in the same boat. So I can see all of the comments. Are these just being streamed in from YouTube? Should we be on YouTube then?
Well, yeah, so these are, going to YouTube. I believe if you, this is a very good question. When I came, I invite a guest. I invite thinking I gave you every, what you call a capability, right? But somehow I think this could be a StreamYard thing. So let me see, because I'm also trying to find out if I can enable you to have comments too.
I can just write the comments on the YouTube, like, you start, mute the response, or the audio that you can start.
That's right. Yeah, so you can respond on YouTube. That's for sure. Yeah, you just have to run your YouTube, but yeah, mute that. So. Okay, good. Yeah. Oh, and then we have folks. Oh, we have Josh too in the audience. Josh and Christian from Seattle, must be from Seattle JUG. Hey. And Lee, I think Lee came. Thank you. Welcome, Lee. Lee came to our previous meetup, a couple of them from Vancouver. So that's awesome. Yeah.
Christian's really nice. On my team at Oracle, works on the Java.
So, awesome.
Hi, Christian.
Wonderful. Yeah, hello.
Nice.
Okay, so are we good? It's already 7:35 Central Time. Is everybody ready? It's gonna be fun. Yes, it's gonna be fun.
Let's go.
Not much formality. It's the key is to kind of just have a great conversation. So I'm gonna start now. So welcome everybody to Chicago JUG meetup tonight. We have a panel discussion with Stuart Marks and friends. And we'll be on Project Amber from the OpenJDK project and more. And let me switch to the next one. But first of all, we want to welcome our special guest today, and that's CJUG, spells C-S-E-A, JUG, and Freddy, and our President Emeritus. So we'd like to invite Freddy to say a few words.
Yeah, no, it's very glad for us to collaborate on this. The Seattle Java user group, like everybody else, have been a little bit of a dormant on this particular times. So I think that we're glad that we can actually start doing these virtual events, and I think that's probably going to we're going to continue that until it's safe for us to meet again and geek out at bars. But thanks for the invite, and we love to keep coordinating and participating with the Chicago Java user group. So.
Yes, so happy to have you join us today, Freddy. Really excited. So finally, it's happening. We've been talking about it for a long time now. You're back tonight. Wonderful. Okay, so we'll move on. So just a few kind of routine kind of words that we need to tell folks. We believe in being inclusive, and we invite all of you to be nice to one another and ask questions and continue to grow in trust and friendship and in your knowledge in Java. Okay. And we'd like to invite you to volunteer if you would like to. It doesn't have to be a kind of a big commitment. You can just come and join and do one event, or just helping us with various things, and that we have a lot to do here all the time. So it will look good on your resume, that's for sure. And also, please remember to sign up with the Chicago Tech Slack if you haven't already done so, and if you like to do so. And we also have our current Java news, and we have Freddy Guime, who's the owner of that, right here, javaoffleaf.com. And please follow them. It's a great podcast. Actually, there's also Pub House too. That's on more teaching, right? That podcast too. We should actually add that back in. But anyway, so join us on meetup.com if you haven't already done so. And follow us on Twitter at CJUG. And now we actually have also, well, kind of not as new now. It's been up for a month or so. Is our Discord channel, and that one too is just a different way of interacting, and it just, we're experimenting with that. So please try that out, and it's just easier for communication, in my opinion. So. And some community info. This is the conference, the next conference where CJUG will be a community partner on December 4th and 5th. That's JLove, and that's the link to them. And they are still having their CFP open if you're interested in submitting a proposals to be a speaker there. And it will be due on Saturday, October 31st at 2 p.m. Central. And Hacktoberfest, Digital Oceans Hacktoberfest. There's still 2 more days, so I'm still kind of reminding you. So all you need to do is do 4 pull requests to an open source project, and then you'll get a free t-shirt. And in Chicago, we have our Open Source Chicago meetup group still holding the local events. If you're interested, there's still some time that you can join. And some upcoming meetups and events in November, we'll be having Michael Manella doing a spring updates, but the date has yet to be determined. And then the 3rd week, we'll have Don Rabb and Sirisha Pratha who, from the Eclipse collections. And as you may know, that they have been rewarded or awarded this top 25 apps of all times for Java this year. So that's a great thing. And actually, Don and Sirisha are both in the audience today, so welcome. And so we'll be having them in November. And then December 2nd, we'll be having a microprofile free workshop, and that will be conducted by the Eclipse Foundation Microprofile Working Group, and primarily will be the Tommy Tribe folks leading that workshop. We'll have more details coming up, and our board member, Josh, who's now also here today too, he'll be actually leading that for the Chicago Java Users Group. So, and then please also stay tuned for our members lightning talks in December. We'll be publishing that soon, so then you can start to prepare for that. And we encourage all of you to submit a talk if you like. And then also in December, potentially too, we may be having Oleg Dokuka from the Reactive Foundation to talk about our socket. That I have yet to confirm. So, and then also we're thinking of an meetup or unconference style. So let us know your thoughts. And this is our jobs board on the CJUG group on LinkedIn. If you like to join that, and you can, recruiters are welcome to post your jobs there too. All right. And a word about our sponsor, JFrog is our gold sponsor. And I think they will be having a raffle, but not this time, but they will be having one in November. So please come to our November meetup. We'll have that. Now, I'd like to introduce to you our featured panel speakers. First of all, Stuart Marks, our Dr. Deprecator, as everybody knows him. And he's a lead member of technical staff at Oracle's Java Platform Group. And he specializes in a variety of JDK core libraries that includes collections, lambdas, streams. So he's here tonight. So ask all the questions you have about these to Stuart while he's here directly. So, and then he has previously worked on Java FX and Java ME at Sun Microsystems. And he's also got a master's degree and bachelor's degree in computer science and EE respectively from Stanford. So that's that. And then we have Freddy. Freddy is our President Emeritus of the current generation of CJUG, yay! Principal developer at Expedia. He specializes in performance and usability. He's also the author and maintainer of the Java Pub House and Java Off-Heat podcasts. Okay. And now we have Bob Paulin. Bob is our board chairman this year. He's also the President Emeritus for 2 previous terms. He's also an independent consultant, specializes in open source for the past 10 years. He's a conference speaker at ApacheCon, Oracle Code One, and DevNexus, and other conferences too, but these are the main ones, right? And he's also a speaker on the Java Pub House and Java Off-Heat podcasts. He's a member of the Apache Software Foundation, a committer for Apache Felix, and PMC member of Apache Kika. He's also a football and basketball coach, although he just told me he doesn't really do much basketball, but I think he does some for his children. So he's a great dad, I'm sure. And then we have our moderator, Paul Nauman. Paul is our board member. He's been a loyal CJUG supporter for many years, but we finally got him on the board after these many years. Thank you. He's also a principal application engineer at Azul Systems. He was previously at Oracle and Sun Microsystems and specializes in JVM and OpenJDK. His hobby includes meta-circular JVM implementations of JVMs written mostly in Java. So those are about, these are all of our bios about all of our panel speakers tonight. And with that, I will hand this over to you. The stage is yours, Stuart. And I will stop sharing mine here. Okay.
Okay, thank you. Let's see. Can you need to put me in focus now or something like that?
You can see we're like solo layout. Okay.
Okay. All right. So I do have a slide deck. So thanks for that nice introduction, Mary. Glad to see everybody here. Good to get together with old friends, even if virtually. So as Mary said, I'm Stuart Marks, also known as Dr. Deprecator. If you see me at conferences, I will wear this white lab coat around, and it has, see if you can see it here. If I have to move a little bit, you have to have a nice embroidered name patch here. So that's how you can spot me at conferences if we, should we be so lucky to get together in person at a conference again. So I do have a quick slide presentation that will kick off some things for the panel discussion. But before I get into that, I would like to have to make a public service announcement. From the Valhalla team has requested that I make this announcement, which is that they are intending to deprecate the constructors for all of the boxed primitive objects, like capital integer, capital long, capital Boolean, all those things. So right now they are deprecated as in the ordinary deprecation. And so what they are going to do is upgrade that to be deprecated for removal. So the Valhalla project intends to remove the constructors for those boxed primitive objects. And so the advice is if you are still calling new integer or new Boolean, then today is a good day to stop. All right, so let me switch over to the slides here. Okay, so how is the slides coming in visible there? Good. Okay, yep, great.
Looks good.
All right. So there's my title slide. All right. So tonight I'm going to be talking mostly about Project Amber, and I'll just do. Sorry. So Project Amber is language features for improved productivity, and so there's too much material here to cover. Trust me, you do not want to sit in front of your computers for the length of time it would take to describe all of this. So what I'm going to do is just touch on one corner of of Project Amber, and then we will see where the conversation takes us. So I think my game plan is to throw a bunch of stuff in front of you, and it will make everybody as confused as heck, and then that'll be nice fodder for the question and answer session. Okay, so I do have to put up this safe harbor statement because some of the stuff here is futures, it is speculative, it is subject to change, and so don't base any product decisions on some of the futures stuff. Some of the stuff I'm talking about has already been delivered, and that is stable, but some of the stuff is futures and is still subject to change. All right, so what is this thing about Amber? Okay, so OpenJDK has a bunch of different projects in it. And so this is the coarse grained structure of OpenJDK. The big project is the JDK itself, and those are the main releases that you see. JDK, you know, going back to 8, 9, 10, 11, and we're up to 15 now. So JDK 15 is the most recent release, and we're currently working on JDK 16. We're shipping those releases every 6 months now, and so the JDK encompasses, you know, lots of individual feature work, new APIs, additional performance, garbage collection, compiler improvements, etc., and quality. Of course, we're continually trying to improve quality. Now, outside of the JDK, but mostly working on stuff that is intended to be integrated into the JDK at some point in the future, are big long-term development projects such as Valhalla, Loom, Panama, and Amber. And there's just so much activity going on there, I really do not have time to do any of those justice. But we are going to focus on Amber today, which is productivity-oriented language features. And I think this is interest to a lot of people because when you're programming in Java, you see the programming language every day. And so so Amber is delivering features that that affect the way you program in Java on a daily basis. Okay, yeah, so that's today's topic. All right, so what are Amber's features? Okay, so there's 6 features that have been delivered or are currently being worked on in Amber, and you can see them here. Let me bring up the next slide here that talks about the status of them. So local variable type inference, otherwise known as var, was delivered all the way back in JDK 10. That seems like such a long time ago now. It's amazing. Text blocks were just delivered in JDK 15. Switch expressions were delivered in 14. And then there's a bunch of stuff. I mean, this doesn't represent all of it, but there are 3 features that are currently being worked on for JDK 16 and being previewed in JDK 16 for delivery in a later release. Those are record sealed classes and pattern matching for instance of. And so let me talk briefly. So what's interesting about these is these 4 features are all, they look like independent features. Like, what do switch expressions have to do with records? And what do records have to do with sealed classes? It turns out they all are designed to work together. And so I will cover that a little bit later, but they are the underpinnings of a coherent direction of development of the language to incorporate a feature called pattern matching or general pattern matching. So I'll talk about that a little bit later in the presentation. Okay, I mentioned preview a moment ago. So what is this preview business? So the idea is, so Java compatibility is very important for Java. So we don't want to deliver something and have people start to use it and then say, oh, you know, actually we need to make a change and then break everybody's code. We really do not like doing that. And so when we deliver something in a general availability release of Java, that is stable. But the problem is, how do you test drive something? With 6-month releases, we don't have beta releases or anything like that. I mean, we do. We do have early access releases, but they come so quickly that it's difficult to get enough feedback within a 6-month time frame. So what we've done is we have a mechanism called preview, where we deliver a feature that is still somewhat speculative. It's defined, specified, and implemented, but it's still subject to change. And so how do we square that with the idea of compatibility? So to use a preview feature it's not intended for production. You have to turn on some special switches to enable compilation using preview features, and also for the JVM to run classes that have been compiled with preview enabled. So this enables you to try to port programs to it or write some test programs and stuff using preview features. But it also, we kind of try to make sure that you can't, we tell people not to run with preview enabled in production, because the problem is that it could quite likely break your code in the next release. So we want people to make an explicit decision to try out preview things, but to leave preview off for things that you are doing in production. So that way we can get better feedback over a longer period of time than the 6-month releases. So this is how it works here. So for instance, taking the text blocks feature as an example, we actually ended up spending a couple years working on text blocks. And so how do you do this if you have releases once every 6 months? So the idea is that you don't work on a feature. It's not like the features you deliver in this release you have a maximum of 6 months to work on them. Instead, you work on them and have preview releases. And then when the thing has evolved and has gotten some feedback and is finally ready, then you say, okay, we're going to turn off for preview and make this a committed part of the platform. So text blocks, there was actually some previous work before JDK 13, but when text blocks came in its current form, it had an initial preview in JDK 13, and then 6 months later there was a second preview in JDK 14, and there were some modifications made there and some changes to the language and the APIs in support of that. And then in JDK 15, we made additional changes to the language and APIs in support of text blocks. But now in JDK 15, text blocks are finalized. That is, they're stable now, so it's no longer a preview feature. So if you run JDK 15, you can just start using text blocks, and you don't have to fiddle with any switches or anything like that. All right, so there's lots of territory to cover in Amber, rather too much, and so I think what I'm going to do for this kickoff bit of the presentation is just to talk about records. And records are, I think, probably the most popular feature of Amber. There was kind of a the kind of a Final Four. What do they call it? Kind of a tournament where there was a contest where people voted on the most popular features in the Java platform, and records came out on top, if I'm not mistaken. So I think there's a lot of interest in that. Records have been previewed. They've been talked about for several years. They've been previewed for the past 2 releases, and now records are progressing. And I believe that the current status is that records are intended to be targeted to JDK 16 as a final feature. That is not a preview feature. So anyway, so what are records? Okay, so records are a class, but they're a class with certain characteristics and restrictions. And so there's a lot packed in here, but basically it's a transparent, shallowly immutable data aggregate class. And so I think another term for records is a data class. There are some constructs in other languages like Scala and Kotlin, I think, called data classes. But the idea is that it's a class that's nothing more than an aggregation of data, and it need not have any interesting behaviors on its own. Its purpose is solely to be an aggregation of data, or almost solely to be an aggregation of data. And now when we talk about object-oriented programming, there's lots of things about encapsulation and inheritance and stuff, and all those things are very important, and using regular classes is still important for that. But sometimes what we find is that all you need is a simple data aggregate, and Java objects have too much programming overhead to deal with that. So that's where records come in. So basically, records consist of components. And a component is a private final field with a particular name, and a public accessor method with the same name. So if you have a field X, if you have a record with a component X, it has a field X, which is private, and it has an accessor method also named X that is public. One thing is these fields are all final, and the intent is that records are immutable. Now, I say shallowly immutable here because you can still have a record containing a reference to a mutable object, and so you can still go modify that thing underneath, but the record itself is immutable. Anyway, so since the record has several components and they're final, they all have to be initialized in a constructor. And you can have several constructors, but the main thing is that has to be what we call a canonical constructor that lists all of the components, and that is responsible for assigning all of the component values at construction time. So what does this give you? Well, so now that we've made these restrictions, we can also let the language do some work for us. In particular, a record has equals hashcode and toString methods defined automatically for us by the language, and so you don't have to type all that stuff if you don't want to. So you can override the constructor if you want to do things like argument validation. You can also add additional methods. Records can also implement interfaces. But there are some restrictions on doing this, such that the complete state of a record consists only of its components, and that's an important thing here. So, and the reason for this notion of the complete state being its components and the components having public accessor methods is for transparency, and I hope to make that clear later with an example. So also in service of this are some restrictions. In particular, you cannot subclass a record, because if you do so, then it kind of breaks the equals method. So if the language is providing an equals method for you, there's no single good semantics for equals in the presence of subclassing. And there's some other things that can happen as well. If you attempt to copy a record, if you do an upcast of a reference to a record and try to copy it, you might end up copying only a subset of the fields. And so that has some difficult and error-prone side effects. We call that decapitation. So basically, it's a fairly severe restriction disallowing subclassing, but in fact, it really enables a lot of services that the language can provide for you when it does that. And then also, as I mentioned earlier, records are shallowly immutable. The fields are all final and cannot be changed after construction. And so the main thing here is this idea of deconstruction, which I have an example coming up later. Yeah.
Stuart, quick question while we're in context. The question was, are we going to get a copy method for records, or is that just object.clone?
Good question. So I think cloning for a variety of reasons is not something we want to support, but copying possibly. Now, so in JDK 16, what we're coming out with is an initial records feature. And so there are some things that are missing. One of the things, though, is that since records are immutable, at least they're shallowly immutable, it's kind of odd to want to make a copy of a record. On the other hand, one thing that you might want to do is to say, all right, well, I have a record that has several components in it. I want to make a new record that has all the same values, except it has a different value for this particular component. So what is being worked on is this idea, and so if you have methods that do that, they copy everything except with these different values. Kind of a convention is built up to name those methods using the word with. And so it's like, well, I want to make a copy with a different value. And so this lingo has developed where people say, well, we want wither methods or wither methods. I'm not sure. I've never actually heard that pronounced. I've only seen that written. So anyway, that is an area of active development. I don't really have anything to say about that. There are a bunch of ideas floating around, but that's something that the languages team is pursuing, is better ways of copying records, but also copying with modifications, I think, is the main thing.
Right. Thank you.
Okay. All right. All right. So here's a little code example. So suppose, it seems like the typical example for records is a point, which is not a particularly interesting example, but it is simple, right? So suppose I have a point being a geometric point having an X and Y coordinate. If you want to be a good Java object, well, so you can see here, class point with two final fields, final int X, final int Y. If you want to be a good Java object, well, obviously you should provide a constructor that initializes those fields. But also, if you want to put, if you want to put point into a hash map or something like that, and have it be be dealt with appropriately, you want to override the equals method and compare the fields. And there's a bunch of goop you have to do because equals takes an object. So you have to, usually, like maybe you do a reference equality check first, and make sure the other thing isn't null. And if it only if it's of a different class, you return the convention is typically that if you're asked to compare equality to something of a different class, then that returns false. And then you do a cast, and then you extract some things from the other object and do some comparisons. So the equals method is actually kind of complicated, and there are a bunch of essays written about that. But it's also very error prone, and so it's very easy to get all these little fiddly conditions wrong. Hash code is another thing. So if you want to play nicely with hash map and things like that, you have to provide a hash code. And what's more, you need to provide a good hash code, and that's actually kind of hard. There's this typical, base 31 sort of thing, which kind of sort of works. It works, but it could be better. And so one of the things we want to do is relieve programmers of the burden of having to come up with a good hash code of their own. And then for debugging and logging purposes, it's nice to have a toString. And what you usually want to do is have a toString method that prints out the values of the fields or the components. And so you have to do that too. Oh, and then of course you want to have your accessor methods. So a point will have X and Y methods to return the X and Y fields. So that's like a whole slide full of code. And that's all sort of boilerplate because equals, hash code, toString, and the constructor and the accessors and stuff really are not interesting to you, the programmer who is trying to create an object that represents a point. That's all sort of goop that you need to do to play with the libraries like HashMap and whatnot. And so with the record, one of the nice things about it is the language provides all of that for you. And so all you need to do is instead of saying class, you say record, you give it a name, and point is the class name here, just like, you say, just like when you're declaring a regular class. And then there's a bit of new syntax here. Here is where you declare the components, int X and int Y. And the language says, okay, you're declaring a record, so that means I'm going to automatically declare a private field X and a public accessor method X, and then also the same for Y. And then now that that's the complete listing of the components of the record, the language also generates for you equals, hash code, and toString. And in fact, it doesn't actually generate, it does generate that code, but it doesn't actually generate the code I showed on the previous slide. There's an implementation trick, which is basically it generates skeletons which use invoke dynamic to run a bootstrap method that actually does some special stuff at runtime to make sure that equals, hash code, and toString actually go faster than the compiler just writing out a bunch of bytecodes to do get and call toString on the components and stuff like that. So there's a lot of cleverness under the hood here, even though you can't see it.
Stuart, quick question on syntax. What's the point of the curly braces? Or are you
good point. Well, so I don't have, I don't have any good examples of this here, I don't think. Suppose I wanted to add another method. An example is like if you're doing geometry, you might want to have the normal of a point or something like that, or the distance from some other point. So you can add methods here. So a record is just like a class, and you can add new methods inside the braces. You can also override equals, hash code, and toString if you want. You can provide additional constructors. You can even override the canonical constructors. So there's a bunch of stuff you can put in the inside the curly braces. What you cannot put in the curly braces is new fields, because the rule I said earlier was the components of a record are its complete state. So that has to be listed in the parentheses following the class name.
Cool.
So,
Thanks.
Thank you. All right, so what do I have next? So what do you use records for? So I have one example here, which is if you ever done any streams programming, sometimes what you want to do is you can send a list of values down the stream, and you can do map filtering, sorting, and things like that, and that's nice. But sometimes what you want to do is you want to generate a intermediate value and have that carried through the stream. And this is actually kind of a problem, because how do the stream can only carry one value at a time, but what you really want is an aggregate. So remember, when I started introducing records, I said this is a simple data aggregate. And sometimes what people do is they'll create a 2-element array, and that kind of works, but it's sort of unclean. Or you can create a class to do this, which is certainly possible, but you can create a little class inline. Actually, you can create a class here. One of the little known feature of Java is that you can create a class inside a method. It's called a local class. And so that is, that's something you can do, but that's just a regular class. And for instance, if you want to, certain things like the distinct operation really want you to have a good hash code in equals, because it uses a hash map or concurrent hash map underneath. So if you just use a class, then you lose some things. So there's a lot of overhead involved, because then you have to write a hash code in equals, and well, you want to debug this too, so you might as well write a two-string method. So creating a class to store intermediate results within a stream is, it works, but it actually is missing a bunch of stuff. So turns out that a record is quite useful for this. So in this example, we get a list of persons, and suppose we want to say, let's take the top persons by some score. Maybe it's Bob's basketball league or something like that. They have individual statistics. But it may be that computing somebody's score, has to do a bunch of searching through the records of games and whatnot. Maybe it's the career score, so it has to search several years worth of games. And so computing a score is not something you want to do within the sort function. What you want to do is, for each person, you want to compute the score and then sort on it, but you really don't care about what the score is. You just want the listing of top of the top person or player. And so that's what this example shows. We start off with a list of persons. We map that to, unfortunately, the name here, person X, is not particularly good, but it doesn't matter, because this is just a local class. So we can declare a record person X, which is just a simple aggregate of a person and a score. And we say, okay, we have some method somewhere to compute a person's score. And so we change each person into a record containing a pair, which is a person and a score. And then we sort on the score, take the top n. Actually, that should be an inverse sorted, but oh well, sorry. Take the top n and then extract the person from that person record, and then dump those into a resulting list. So it's really convenient for things like that, because all you need to do is declare one line at the top of your method, which declares this new type, which is this simple aggregate. All right, now I'm going to start throwing some curveballs here to continue the sports metaphor. Actually, it's obliterated. It's obscured here. The title of my slide is Records, Sealed Classes, and Switch Expressions. And so what I'm going to do is very briefly try to cram in a bunch of different Amber features on a couple slides. So briefly, a sealed class or a sealed interface is one that restricts what subclasses it can have. And so there are a variety of ways to do that already. For instance, if you have a class, you can make it final, and that prevents subclassing. But sometimes you want to have a family of classes that is restricted to a particular set of classes, but you don't want to allow applications to extend those. You can do that with an abstract class, by making sure that you protect all your constructors. And that also means that your implementation classes have to be in the same package. So you can get it done, but what you have to do is you have to carefully balance a bunch of different things, and you have to get it right in order to make that happen. So if you have package private constructors only, and if all of your implementations are in the same package, then that prevents somebody outside the package from making a subclass. But sometimes you don't want to use abstract classes. Sometimes you actually want to have an interface, but restrict subclassing. And that's what a sealed class does. So here I have an example, sealed interface shape. And implicitly, there's a permits clause that says what subclasses I permit. But if that's absent, then it restricts it to the things in this file. And so shape has 3 classes defined inside of it. Circle, rectangle, and triangle all implement shape. And since it's sealed, the language knows that there can be no other subclasses of shape other than circle, rectangle, and triangle. And so here we have variants of shape that have little bits of geometric information, like a circle has its radius. And so by coincidence, by not coincidence, the examples here all use records. So a circle record has just radius, and rectangle has width and height, and a triangle has its base and altitude. And so this is future stuff. And here's what I want to specifically call out. Sealed classes are previewed in JDK 16, still subject to change. And some of the stuff I'm showing here and on this next slide are also future features. So this syntax is, I don't even know if there's a compiler that implements this syntax yet. So there's a lot of stuff going on here. So one is, this is a switch expression. Now the switch expression itself is a finalized feature. So that's in JDK 14. And so the idea is you can have a switch that returns a value as opposed to branches to particular statements until it hits a break statement or a return statement. And so what this does is, like a switch, you give it some argument and then it chooses one of the cases. And then this arrow syntax is a convenient way of saying the value of this expression, if there's a match with the case, is whatever the expression is on the right-hand side of the arrow. And quick note, this arrow is not a lambda. It's just a piece of the switch syntax. So anyway, but you can kind of see what's going on here, which is we know that we have a shape, and that shape interface is sealed and has exactly 3 implementing classes, circle, rectangle, and triangle. So we can write a switch expression here that says case circle, case rectangle, case triangle, and then does something appropriate for each of those. But notice we don't have to provide a default clause, because we know that there can be no other subclasses. And this is actually a very powerful thing. And this is very important, because if we added a default clause, what would you put there? Well, you could say, default throw assertion error, this should never happen, or something stupid like that. Or maybe you return a default value, like in this case. Well, what's the area of something we don't know about? Maybe return 0. I don't know. The problem is, if somebody goes back and adds a new kind of shape, like a pentagon, that's going to fall into the default case, and you might get the wrong answer, or you might get a runtime exception, and that's a problem. And so the idea is, if you have a sealed class hierarchy, then switch can be proven to be exhaustive. And so when you compile this, if somebody were to add a pentagon to the shape hierarchy, but you didn't update the switch, that would be a compile time error that says, hey, you need to handle pentagon here. And so that's a service that the language is providing for you to prevent a whole class of errors. So there's another thing going on here, which is there's this weird syntax, which is there's something you can't do in Java today, which is do a case on the type of something. And so that's something we are considering adding. But also, what's to the right of the word case here is what looks like a constructor. So it says case circle var radius. what is that? And so that's actually not a constructor, it's a deconstructor. So what's going on here, this is where we get into pattern matching. The idea is we take a shape, and what this case is saying is, if this shape's type is circle, and we know it's a circle, and therefore it has a radius component to it. And so we can extract the radius component and then make that available in a variable, and then use that in the expression that immediately follows it. So you can imagine what this, I guess I should have had a slide that had what this code would have looked like before, which is, you would have had to say an if-else chain. If it's an instance of circle, then downcast it to some other variable of type circle, and then extract the radius into another variable. And so it adds a few lines of code for every single one of these cases. So what's going on here is we have a type pattern match and extraction going on. And this is something that one of the features that's being worked on in Amber right now is doing that for instance of, but one of the things that is futures, and there's no JEP for it yet, is to do type matching and pattern extraction inside of a switch statement or switch expression, which is what I've illustrated here with some example code. And again, the syntax is the syntax is speculative. It'll probably look something like this, but there may be some variations in it. But anyway, there's a lot going on here, and once you have these facilities in the language, they all play together in a very interesting way that can really make your programs a lot better. All right, well, that was a whirlwind through Amber, and I'll leave this up for a while so that you can look at the links. There's lots of documentation and writing about this. The main Amber project page there is on OpenJDK. Gavin Bierman and Brian Getz wrote a paper about pattern matching for Java, and that really covers all of this stuff in a lot of great detail about the ideas for what we have implemented and continuing to work on in the future for pattern matching in Java, including some of the stuff I said, like type pattern matching and most notably extraction and deconstruction of objects into components. And then a few weeks ago at the Oracle had an online event a few weeks ago. Gavin Bierman, who's on the languages team at Oracle, is leading the pattern matching effort, and he gave a talk on. I mean, it mostly covers this, but also some other language features, and that's available on YouTube at that link right there. Okay, so I think that is I'll leave this up for a while so you guys can copy down the URLs, and so I want to toss this back to the panel to see if any questions came in from the chat, or if they have any questions of their own, or if I completely confused everybody.
Oh, I got plenty of questions.
Okay.
Yes.
Fire away.
Yes.
Right.
So look, I mean, do we want to take one for the chat, or do we want to start off?
Up to you guys.
I know we've got a little bit of delay on the chat, so maybe we start with each other because we're real time, and by then the chat will catch up.
Well, actually, Bob, if you don't mind, we actually have we've got a couple of questions that came in very early, and they're very specific and very pointed. So maybe we'll jump on those first, just because they've been waiting for so long. Is that okay? Okay. So David K asks, Stuart, why did you choose not to add map, filter, and flat map directly to the list interface?
All right. So this is going back to Java 8 and the addition of the streams API. And so one of the things there is the collections APIs are geared towards in-place mutation. So there's add, remove, and so forth. And the streams APIs are geared towards lazy value propagation. And it's certainly possible to add things like map, filter, flat map, and whatnot to collections, but the question there is that would potentially be confusing, because now what does map mean on if you call map on something, it actually means something slightly different from map on a stream. So if you call map, filter, and flat map on a stream, then what you get out of that is a stream of additional values. If you were to call it on a collection, if we were to add it to the collection, would that create a new collection? Would it mutate it in place? If it created a new collection, what would be the implementation class of the collection? Would different collections be responsible for deciding what what collection implementation to use? So it's certainly possible to do so, but it actually raises a bunch of confusing questions. It would certainly be convenient, but and sometimes it's nice, but it's also one of those things where it would be nice to add some things that are convenient, but we mostly hold off doing that because it adds a lot of surface area to the API, but doesn't necessarily add any additional power to the API. So something that people want to do often is, I have a list of things and I want to transform that into a list of other things. Why can't I just call map on that? Okay. All right. Now, suppose you want to, you can do that. There's actually a replace all on the map. And what that does is it gives a lambda, it calls a function, calls a lambda for every element of the list, but the replacement element has to be of the same type. So sometimes you want a list of a different type. So how do you do that? Well, you have to say, list.stream.map.collect to list. And, that's a little bit of a mouthful. On the other hand, there's, some other questions that arise, right? Suppose I want to control the implementation class of the result. Okay, well, now we need a new variation of the API for that. Suppose I actually want to, suppose I don't want to do that. Suppose I only want to transform some of the elements, but not all of them. So now I have to figure out how to put a filter in. So it's like, it's certainly possible to put in a convenience API that does this one exact thing, but it doesn't buy you all that much and it adds clutter to the API. So I think we decided to keep the higher order functions like map, filter, and flat map on streams because they're fairly well defined there, and add specific things to collections like remove if and replace all are on list, and those are clearly eagerly evaluated in-place mutation methods, and those are what belong on the collections.
Mm-hmm. Plus, you already have the linkage from collections to streams with the collection.stream method, right? In the collection interface. So.
Yeah, and it is an issue. I think we wrestled with this because it means that you basically have to do a couple extra methods. You have to convert something to a stream and then convert it back from a stream. And that does add a certain amount of code overhead and code verbosity. But it's a trade-off. I think that we could add more stuff to the collections, and I think we're considering doing that. But I think we're basically trying to avoid API proliferation here. So we're trying to be minimal, oddly enough.
Right. Okay. All right. And one more from the same person. Stuart, are we going to get extension methods?
Not as such. I think there's certainly some discussion about that, and so I think the idea here is that I guess it is Kotlin and C# have extension methods which are which basically allow, if you have a library with that defines certain interfaces, and interfaces have methods on them, then the consumer of the library can add things that look like methods on that interface. But really what they do is that's just some kind of syntactic sugar to a static method that's defined somewhere else. And I don't think we are going to do that directly. I certainly see the value in that, but it also has a that has a cost as well, because what it means is that if you have a reference that is of some interface type, and then there's some method call on it, then there are a bunch of different places you can get that method definition. And so it looks like it's a call on that interface, but it's not. It's actually defined somewhere else. And in Scala in particular, there are implicits which get applied. And if you're not an expert on implicits, then this stuff appears out of thin air by magic. And so it can be pretty hard to figure out what is actually going on with those. That said, there is this issue, and this comes up with things like streams, where it'd be nice to, stream has a nice family of operations on it, but sometimes you want to add one more. And you can't really add one more. You can't chain methods onto it of your own. And so there is a need for that. I just don't see extension methods being exactly the right way. Maybe there, occasionally comes up, deciding on some alternative syntax for that, or something like that. So that's something that's been kicked around, but no concrete plans for anything like that at the moment.
Okay, cool, awesome. Thank you, Stuart. So Bob and Freddy, I'm betting you guys are chomping at the bit. Mary,
Oh yes.
Mary, maybe it's time to switch this over to the panel format. There we go.
Yay.
I will switch back to my. Okay, look at that. Wow.
Awesome.
Studio here.
Okay. All right. So Bob, I think you chimed in first. Sounded like you had a.
Oh, sure. I'll go first. No, I mean, so great presentation, Stuart. I mean, there's so much content to go through. I wanted to start off kind of by building on one of the first questions that was asked, and the popular feature, the records. With records, the question was asked about copy and whether copy made sense, since if it's all immutable, you've really only need one instance of a record, or really one object of a record, since you can't change it afterwards. So the underlying implementation still allows you to have multiple objects with records. Is there any way of looking at records as, hey, once I create a record of this type, do I really need to create more memory overhead for that? Or is that something that you guys have looked at? Because I think the underlying implementation is still an object. If you take a heap dump with a bunch of records, you still have 4 objects, even if they're exactly the same.
Right, exactly. So
Interning records.
Sorry, what's that?
Interning records.
Right,
So,
exactly.
Yes.
So anyway, so I think your starting assumption is correct, which is that records are mostly ordinary classes. And so basically you call new and you pass in some stuff. And so they're stylized classes that have these things we call components, which are basically fields and methods that are following a particular convention that's enforced by the language. But otherwise, in the implementation, yeah, they're just classes. They exist on the heap. And since they're classes whose instances are on the heap, you have references to them. And if you create another record with the exact same values, then you will get a different object that compares that are not identical, but they will compare dot equals true, right? And so that's just like regular classes. And so where do you take that, right? So do you want a way to enforce that there are? I mean, there's no way out of the box to enforce that there will be exactly one record with any particular value. You have to kind of do that yourself. I don't know if anybody's talked about singleton records. I suppose you could come up with some convention to do that, but usually the point of singletons is to encapsulate some bit of state that you want to make sure that it has exclusive access to something like some resource. And so generally the idea is, I mean, if a record is really nothing more than an aggregation of its values, then you shouldn't need to care whether you have multiple instances of it or not.
Is there a specific concern, Bob? Is it just
it's
heap
not
space?
more of a concern. It's all, yeah, I mean, it's all
memory,
heap
that's it,
space,
yeah.
and it's all just kind of looking at the implementation and the intent. And is there an optimization there? I mean, the other question is, hey, when you throw value types in, do you have value type records where you're going to put, records on the stack rather than in the heap?
Right. Yeah, and so that's actually more the direction we are going, right? So this is
more of a struct.
Yeah. Well, I hesitate to use the word struct because if if you're a C programmer, then a struct is a region of memory that basically has has names assigned to different slices of it and you can read and write from it, right? So I think the point about value types is a good one, right? So I think the intent is, if you are concerned about instance control and records and stuff like that, then the idea there is to look for the Valhalla stuff, where it becomes less of a concern about how things are created and garbage collected. And so also there's a lot of vocabulary changing going on. So Valhalla was named that because the original effort was about value types. And for a variety of reasons, that's the Valhalla team felt that was confusing, because actually the problem is it's an overloaded term, right? Because if you're looking at the definition of the programming language, for instance, if you have an expression, you evaluate that expression, and that evaluation produces a value. Well, that's true of integers, or it could be true of anything. It doesn't have to be a value type. Well, what's a value type? A value type that is a value class or whatever, right? So it became very confusing because the term value shifted in the middle of the sentence. So they said, yeah, we should probably use a different word. And so for a while, they were using the term inline classes. And that was more descriptive, because the idea is that if you have, say, an array of Java objects, the array doesn't actually contain the objects. It contains reference to those objects, and those references are to somewhere on the heap, and so those objects have to be allocated elsewhere. The idea of an inline type is, and this is kind of where the idea of a struct comes in. Like in C, if you have an array of struct, the array actually contains those structs. And
inline memory. Yep.
So if we have inline classes, and you allocate an array of inline classes, then the array actually contains those instances, not references to somewhere else. Mm-hmm. And I think that's descriptive, and the team actually ran with that terminology for a year. But there was this other problem, because this is a fairly deep concern here, and I'm not sure I'm going to be able to represent it. But it turns out that if you have one of these newfangled classes, it might be allocated on the stack, or it actually might be scalar replaced or passed in registers or something like that. And that's definitely what we want. But there are times when the JVM might decide to allocate one on the heap anyway. And it's like, well, gosh, what does that buy you over a regular object? And what it buys you is that the JVM can make that decision transparently, and it can change its decision transparently. So for instance, if it's calling, so the interesting thing about one of these new types that Valhalla is trying to define is that it can change its nature depending on who's using it. And so if you have a class that knows all about inline representations, then the JVM can do all the stuff about passing things in registers and doing escape analysis and scalar replacement and whatnot. But sometimes you might call a method that takes a parameter of type object. You don't know what that method is expecting a reference. Mm-hmm. And so at that point, the JVM says, I'm not sure how this would be done. I think there's some JVM magic that actually I don't quite understand. But I think at link time it says, okay, well, so since this is an inline instance, but we're calling something that might expect a reference, we might actually have to do a heap allocation, copy it to the heap, call that method, which does what it wants with it, and then at some point later decide, okay, actually we don't need that heap anymore. We're going to transfer it back onto the stack or scalarize it again.
Oh, fun. And we wonder why Valhalla's not done yet. Very good.
What happens with generics and collections then?
That's exactly where the issue comes in, right? So if you look at so here we're pulling on this thread here. So
Project Amber.
Yeah, I know. We were supposed to cover Amber, and we're in Valhalla.
I went for a little segue, but we're just, the black hole is too strong.
Yes, spiraling out of control. Anyways, we can't stop now.
Yeah. So let me finish the terminology issue. So the problem is we've stepped away from calling these inline classes now, and the new terminology is primitive classes. And a primitive class, and I think I'm using the terminology right here, right? So what I just described was a primitive class. It's the same concept. It's just a different name for it, but it codes like a class, but behaves like an int, right? So you don't care whether an int is actually on the heap or in some register or on the stack somewhere. So the idea is if you have one of these new kinds of classes that we're now calling primitive classes, you don't care if the JVM decides to put it on the heap or put it on the stack or scalarize it into registers or whatever. The VM takes care of that for you. However, what I was just describing was sometimes the VM will decide to create those on the heap. And that's what's called a reference projection of a primitive class. And there are times when that's necessary. And I'm not entirely sure of exactly when those are. I think I came up with an example which might be true. Mm-hmm. You have something that requires that eventually needs to expects. If you have a method that expects something that is a reference, then the VM will make sure that there is a reference for that. And so that means that the something that was a primitive essentially has to be boxed. I mean, it really is kind of the same kind of thing going on.
Right, which the compiler does, right?
Well, okay, so in the language, right, we have this duality between int and capital integer, and that is done by the compiler. And one of the problems with that is that it works about 90% of the time, but some of the time you really have to be aware that you're dealing with objects, right? So it's the usual thing where if you're comparing, usually it's kosher. It's kosher to compare two int values using the equal operator. That makes perfect sense. But if those get boxed into capital integer values, now you're doing reference comparisons.
Oops.
You're going to have two different instances of the capital I integer 1000. And so they will not compare the equal operator will return false. And that, that's a common, that's the problem with auto boxing, because it's done in a very shallow layer in the compiler. And there's some syntactic sugar where you don't have to convert between boxes and primitives, because the JavaC compiler does that for you. But that's not known to the JVM. Those are completely different things as far as the JVM is concerned. So the Valhalla idea of primitive classes and reference projections of primitive classes is a mechanism that the VM is providing for you. So as you, the programmer, only in very specialized cases do you have to be aware of those differences. And collections might be one of those, right? So to get back to Freddy's point here, is one of the problems with collections is that collections, as they exist today, can only contain reference types. So if you can have a list of string, but you cannot have a list of int. And so there are lots of specialized libraries that have list-like objects that contain an array of int, for instance. And that's a fine thing, but they cannot actually implement the Java util list interface, because that's all specified in terms of reference types. And the alternative, of course, is to have a list of capital integer, which means that everything you put in there has to be boxed. And so that imposes a tremendous amount of overhead. So one of the design goals of Valhalla is to pursue a line of development called primitive. Sorry. It's to pursue a line of development called generic specialization. So the idea is, as conceived in Java 5, generics only applied to reference types. And so the idea is to expand that to also allow primitive types. So in fact, you can, and primitive classes. So you can say list of int. That's the idea. And then the idea, and then further, the idea is that those not be boxed unless absolutely necessary. So really, the design goals, if you have so right now, if you look inside the list implementations, there's an array of Java lang object, and so that's what I was talking about before. You have an array with references to things, and so if you create a list of int, then that should have an array of int in it. Mm-hmm. And that's the design goal there. And there's actually going to be a lot of heavy lifting that goes on there. I think the VM and language guys have some pretty good ideas about how to do that, but that's still a work in progress.
Mm-hmm. Yeah. But that's it's a friction point that pretty much every Java developer hits often, right? Is because collections are super handy and primitives are everywhere. So
yeah, I think it's like a hidden cost. Like you sort of start paying attention to it once you get bitten by the boxing and unboxing, and it's like, oh my gosh, that's, so yeah, it's something to be aware of.
Yeah. Okay. Yeah. Cool. Thank you, Stuart. Unless there's more to say, go ahead. There's always more.
I wanted to bring this back to records, right? So we started off by saying, well, what about records versus Valhalla stuff? And so these are actually orthogonal features, right? So right now, and in the future, a record is just a particular kind of class that has some strong conventions enforced by the language and the VM. In the future, we will expect to have primitive classes and primitive records. So the idea is you can have all four of these. You can have a regular class, like a class of reference type, or you can have a primitive class, or you can have a regular class. Sorry, I'm kind of gesturing off screen. So there's a 2x2 matrix, right? So you can have something that's a regular class or record, or you can have something that's a regular class or a primitive class, or you can have a primitive record, or a primitive record class, actually, I think. And so, for instance, the that point example, point XY, right? That might be a good candidate for a primitive record class.
Right.
Because if you have an array of those, you will want those to be all inlined in the array and just have a succession of XY values as opposed to pointers to somewhere on the heap to a bunch of very small objects. And in fact, so let me run with this now that I'm on a
you just have to nudge him.
Yeah.
Yeah, right.
What I said at the beginning was about the Valhalla team and their decision. They're going to try to make the box types for primitives. They're going to try to turn those into primitive classes. And so, this is the intent is to try to fix auto boxing for real. And so, I think there's going to be some rough edges around it because, maybe I shouldn't get into that. That'll be off the deep end. But the main thing is what we want is capital integer to become a primitive class. And so the other thing is, it should not necessarily have to create boxes on the heap for everything. So the other angle on this is if you have a list of capital integer, then inside that turns into an array of capital integer, not an array of object, or maybe an array of object. It's not clear. But conceptually, it'll turn into an array of capital integer, but those will be primitive classes. And so the actual int values will simply be right there instead of being references to things on the heap. Yeah. So the intention is that all that data be inlined.
Awesome.
Wow.
So-
Freddy, you got one?
So back to the very beginning.
So back to the very beginning.
It
So one of-
ties into Amber.
Yes. Well, I don't know if it really ties into Amber, but everything is deeply intertwingled, to steal a phrase from Ted Nelson. So what I said at the beginning was that the constructors for the box primitives will be deprecated and removed.
Because of this.
So if there's code out there that calls new integer, the problem is code that calls new integer expects to have a reference. And furthermore, it expects to have a reference that is unique, that is not equal to any other instance of anything in the system. And that is completely at odds with this idea of a primitive class, like an int, where you don't care. There's no reference to an int. An int is just a value. It can be on the heap, or it can be on the stack, or in a register, or whatever. So we want to make sure that applies to java.lang.capital integer as well.
Mhm.
But in order to do that, we actually have to take away the public constructor.
Mhm.
And so we are starting. I'm not sure exactly where this is, but I think basically the team made a decision, and one of my colleagues said, "Hey, Dr. Deprecator, can you make sure to tell this every chance you get?"
This is your thing.
It starts today.
That's right. Yeah.
I'll say that it probably is going to hurt.
I don't know. I have not used that constructor in some time. I've kind of
haven't.
moved off of it.
Yeah, but there's tons of code there that probably still have.
Yeah, probably.
Sure.
Yeah.
Sure.
Yeah. Anyway, so that's early foundational work, if you will, for Valhalla, is getting those constructors out of the way.
Yep.
Yeah. Okay.
Now, I did have a question on Amber.
Oh yes.
So going back to that switch statement that you were showing, where essentially we're doing using records, right? So switch on the records, and then the idea of the deconstructor, where you are specifying essentially the members or the record, essentially the record members. Why? The first question that comes to my mind was like, why not just have a reference to a casted reference to the record itself and let the user just access the fields as part of the expression? Because it seems like it's a lot of like, it seems like for the deconstructor to work, there are certain things that you need to put in. Like the order has to be the same. The declaration has to be the same for it to know how to deconstruct to the disconstructed variables, right? It seems like it would have been easier just to, and I'm asking because there's probably a reason why it was done that way, but it seems like it would be easier just to pass a reference to a cast record of that type.
For simple cases, it might be, but I think the idea is that pattern matching can go much deeper than that, right? And so I think I don't think the syntax even exists yet. But imagine a rectangle which is defined by two. Imagine a record which is a rectangle which has 2 points, upper left and lower right, and then each point in turn has an x and y, and so you can actually nest the deconstruction there. So I can say case rectangle point x1 y1 point x2 y2 and extract all of those in one go. And furthermore, the idea is you can also do conditional pattern matching on the values. And so if you want to deal with a canonical geometric example is I want to deal with circles, but I only want to deal with a unit circle whose radius is 1. And so you can say case circle I don't know what the syntax would be. Could you say case circle 1, and that would only match if the thing was of type circle and if its radius was 1.
I see. So the question is like the deconstructor we saw is really doing pattern matching on the deconstruction parameters to the actual record. So it doesn't need to be a declaration of the same. Like it's not like you're declaring I can omit parameters if I wanted to. Then is that? in the deconstruction?
You know, I don't know. I think this is all sort of speculative at this point. And I think the idea is if there's a parameter you don't care about, you can use an underscore. That's one of the working things. And so there's some long-term thinking here. You might recall that I think it was Java 8 and earlier, underscore was just a regular identifier. And there was this little change that got slipped in that said disallow a single underscore as an identifier. And so there's some people who are mad about that. So they went and did a global replace for underscores to double underscore or something like that. So why is that? Well, so the idea is to reserve that single piece of the namespace to mean something special. And you can sort of see this in Scala. I think there's I think, is that called the Wunderbar? I'm not sure.
I forget the term, but yeah, it's definitely Scala. I know I've seen that.
There's a little bit too much magic going on in Scala's use of the underscore, but I think one of the things is that there really is a need to have. So one of the things is when you do these pattern matching deconstruction, you have to make up names. And sometimes you want to, and so if you're going to use it, then what you do is you come up with names and then values are bound to those names. And then you can use those as local variables. Great. But sometimes you might want to do a match, but you actually do not care. And so one thing that the language lacks is a kind of special name that, you know, as you observe, the parameters are positional.
Mm-hmm.
So you know, there are times when you might want to do a match and say, I don't care about the second thing, but since it's the second thing, I have to put something there because I want to do something with the third thing.
Yep.
And so there really is a need to have something like underscore. Well, there's a need to have some kind of placeholder, and underscore is the intent is to use the underscore as that placeholder.
Does that kind of feed into Freddy's suggestion if you did have a reference to the record itself and you could just call the getters inside? Now that I'm trying to remember your example from before where you actually had this case statement up, but is there a scope where you could even pass it in almost like a Lambda expression, but where it's kind of bracketed off where, you know, it's like, I'm talking about this record, call this getter. Well, it's not a getter, but it's a component accessor, I guess you'd call it.
Yeah, one of the things is I skipped over the pattern matching for instance of stuff, and maybe I should go over a little bit of that. So Mary is on. Can you make the full screen again? Thank you.
Alice in Wonderland.
Yeah. Okay. So this is an example with instance of. So this is what's the state of this? This is in preview for 16. It's called pattern matching for instance of, and eventually this could equally apply to cases of the switch statement. But I think there's something going on here, which is, so this is the conventional thing. If I get some object and I want to do a test, whether it's an instance of something, I have to downcast it before I can use it.
Right.
And so then I have to go over here to advance to the next. Okay, so that's the equals method where this is particularly painful. So you have to do an instance of test and then do a cast and then do some extraction.
How many times have I done this?
Exactly. So I left off. Actually, you can see the syntax here. So here the idea is you can say, instance of this class, and then you put a variable name that right after it, and so that's kind of the first level extraction where it provides the casted reference for you right there, and then the scope of that variable is the rest. Actually, the scope rules are very complicated. But if you have a case like this, since they're all joined by and, then that means that that variable is in scope for the rest of the expression.
That's it, though. Oh.
Yes. Yeah. It's actually very sophisticated.
I was going to say, is there any other example of that in the language? This looks like a new type of scope definition.
This is new. In fact, this is, if you look at the pattern matching for instance of stuff, Yeah, I think most of the work is pinning down the scope of variables that are declared this way.
Mm-hmm.
And it's, well, I it's actually very interesting because all right, I'll just state this, and it might horribly confuse people, but there's a lot of flow analysis that the compiler does, the JavaC compiler does as a requirement of the language, having to do with definite assignment. And so it's like, well, what is all this stuff? If you have a local variable, if you just say, int x inside a method, that's a local variable. If you try to use x before it's initialized, that's a compile time error.
Yep.
And so suppose you initialize it conditionally in like an if statement.
Mm-hmm.
And you try to use it after. Well, the compiler actually does flow analysis, and it says x might not have been initialized when you get here. So the compiler actually goes through all the code paths between the declaration and use to make sure that a local variable has been definitely assigned.
Mm-hmm.
And that is the if you look up in the Java language spec, if you look for definite assignment, there's a whole section on this. And it turns out that and then there's also a counterpart called definitely unassigned. So the language guys will always talk about DADU analysis, definitely assigned, definitely unassigned analysis. And that's all this flow control, or not, flow analysis over when local variables are assigned. And it turns out that the scope of things like this implicit cast declaration here is quite related to that, because essentially the variable isn't, imagine you were able to put this, it's a local variable declaration somewhere in the midst of an expression. So at that point, that variable is a local variable that has been definitely assigned. And so what parts of the method or expression that follow is this variable definitely assigned? Well, it turns out that they said, okay, well, the scope is pretty closely related to that. And so if you attempt to use that variable where it has not been definitely assigned, the compiler detects that and says, oh, that's an error. You can't use that there. And so, for instance, if you change one of these ands on the subsequent line to an or,
then
it might not
there's
work.
Short circuit evaluation.
Yeah. So it's actually pretty sophisticated. Those guys spent a lot of time working out the scope rules, and it's pretty hairy. But
no, because I was thinking like I was always impressed that the Java will tell you might not have initialized, even though it might be a very deep nested, sort of complex statement that you're working with. And actually, now that I think about it, so they must have taken into account the use of labels as well. So the infamous ability to go to essentially break out of an inner loop, and then as part of knowing that if it was definitely assigned or definitely unassigned, I'm just thinking about all the edge cases that you have to do for these things. That is hairy.
Yeah.
I'm glad that the JVM does it.
Yeah. One of the things, I guess this is more of an observation, is just, take me back 10 years of where you were looking at language design like Groovy and things like that, where the language constraints were kind of being teased away, where it's, hey, we're going to add methods at runtime, and we're going to, allow you to dynamically do all these things. And it seems like 10 years later today, it's like, we're going to add all these constraints now, but look at what that lets you do inside of them.
Yeah.
It's, with Kotlin and Java now, all the things that you're talking about, adding records, these things for pattern matching, a lot of it is kind of locking some things down where we're going to seal things up so you can't add more, but it allows your IDE to do autocomplete, because it's like, hey, I can look at the compiler, I can see what's going to come next. There's only a certain amount of things you can do here.
Statically typed language.
Yeah.
So just an observation. It just seems like directionally that seems like the trend now, because I know on my Groovy IDEs, it's just like,
I don't know.
It's still cooking. I don't know what you're going to do next. You can type anything you want.
Oh gosh, no, you know what? I like that. Like that is true. Like it's interesting because like we always you know, not we, but like people will say like, oh gosh, you know, Groovy had this or Scala had this. I'm perfectly fine for Java to, you know, let others try it first, and then let's see what kind of problems we run into, and then after you know some time of them like figuring out, you know, what kind of thing broke, then bring it here like into the Java ecosystem. So I'm fine waiting. So
that's another really good point. Stuart, to you, with the 6-month release cycle and having the previews, just to go back and look at, are you guys getting the type of feedback that you were expecting from that? What's kind of the pros and cons now that you've been doing it for a while with the 6-month release cycle and these features?
Yeah, that's a good question. I think we I think the preview stuff, I mean, it on the one hand, it feels like it's a little over-engineered. On the other hand, I don't know if there's an obvious alternative, because I think what was clear, so if we think back to the big releases like Java 8 and Java 9, we would deliver early access releases for those regularly. And even with, both of those were 3-year releases. And even with early access builds, we would come out with a new feature and just a very few people would try it. And then there was actually a lot of pressure, because even in a 3-year release, it takes you a while to design and develop a feature, and then it gets into an early access release. And then you get some feedback from it, and you try to make some changes, and you pretty quickly start running out of time. It's pretty amazing. And in fact, those were, both 8 and 9 were originally 2-year releases, and there were a variety of reasons that those slipped. But things like that ended up, you know, putting on more pressure to slip things. Or you know, and then there's this terrible thing, which is, you know, if the feature isn't ready, we drop it out and you know, wait for the next one, which might be 3 years from now. It's like, you know, who knows where you're going to be 3 years from now. So I think the preview mechanism is a way to decouple the feedback cycle from the release schedule. And so from that standpoint, it's necessary. I think there's this idea that there's a certain, so we do, I mean, so we can always use more feedback. The best kind of feedback is somebody saying, gee, there's this new feature. I downloaded, you know, either an EA build, or I downloaded JDK 15, and I tried to write a program using enable preview, and it didn't do what I expected. Or I wanted to do a program that did this, but it didn't work for me because such and so, or something like that. And I think there's this idea, which we don't have any hard data on, but it's kind of intuitive. There are a lot of people who are more likely to download a GA release of the JDK than some early access build, because, you know, I'm so close to this. I look at all of the early access builds. So for me, switching JDKs, you know, I do it right and left every day, right? But that's what I do, right? But that's me, right? Most people, oh, JDK 15 came out, maybe I'll take that and play with it. But they don't bother with all the early access builds, right? So the fact is, okay, well, I'll port my system to it and see if they, you know, see what the GC, you know,
performance.
I'll try some GC, you know, my GC stress test on it and see how JDK 15 does on that. And then, you know, since they have JDK 15, maybe they're playing with it, maybe they're doing some pre-production testing or whatever, just to see, you know, some other feature. Then we can say, oh, have you tried records? Oh, no, what's that? Oh, well, if you already have JDK 15, just do enable preview and you can try records, as opposed to download an early access build. So our hope is that having preview features in GA releases will get us some more feedback. And I kind of think that's true, but it's not like we collect data on it. But anyway, that's the idea. And also the necessity is to, you know, if we didn't have preview features, then, you know, we wouldn't be able to have these intermediate forms of things like text. Well, all of the Amber features, we've basically settled down to at least 2 rounds of preview before before going final. And so I think that gives us, a year of development and feedback and stuff. And having those, our sense is that having those in preview as preview features in GA releases is a good thing. But
so cool. Thank you, Stuart. So let me switch it around actually to you, Bob and Freddy. You guys are practitioners and are, you're out in the field. You've been kicked out of more places than most of us have been in.
After 5 years,
I think it must have been all those shots.
yeah, that.
So I'll start with you, Bob. How do you see these new features being adopted? Right, they're clearly the hardcore cadre of professional Java programmers are looking at these things and playing with them and hopefully giving feedback. But the lumbering behemoth of the corporate world, right, is following distantly behind, and someday is actually going to hit these features in a big way. Mm-hmm. And do you see that happening earlier now, is with the 6-month cadence and the previews, or are they still just kind of staying far behind on JDK 8 and waiting for a safe step?
It depends on the organization. So at the corporate level, my experience, and I don't know if Freddy, you've had similar, is the long-term releases have a lot of gravity to them. So there is a little bit of staying away from the ones in between, but 11 and 8 are definitely getting a lot of play in the corporate environments. What I'm seeing in the open source projects, though, is probably early adoptions. I mean, I know I'm on the Tika mailing list. They subscribe to the early access mailing lists, and they do pay attention when a new release comes out. If you look at some of the Apache Jenkins builds, you'll see 14 and you'll see 15 mixed in there. So the open source community is definitely a little bit more cutting edge than the corporate community in getting out into some of the more edge releases. Now, I've still not seen a ton of early access. There are a couple projects that do test on early access, and there is still a little staying away from the new features in the early access, since it's an open source project and you're really aiming to release on something that's GA. Mm-hmm. But I do see that at least kind of picking up a little bit on those projects that want to be day one ready for these releases when they come out.
Okay,
Freddy, what do you see?
Yeah.
So it's interesting because, like, for example, we have motivation to move from 8 to 11 at some point in time, right? Like, we wanted to adopt OpenJDK 11, and the thing that we discovered, right? Like, it was an interesting move because even though we were late adopters, meaning OpenJDK 11 was there for a little bit. The things that hurt us the most is that not necessarily the language, is the dependencies that we have, right? Like, so all the libraries that we bring, like when we made the migration, Gradle broke, Maven broke, and we were downloading Spring version 1.5, and we needed to it forced us to do an upgrade for it, right? So the thing that we see is is even when we are late adopters, sometimes we have to be late adopters because the tools and frameworks that we use are not necessarily there yet for us if we wanted to move at the sort of not the long-term releases, but sort of the immediate releases. So and it tends to be where I work at Expedia Group, that we have projects of varying sizes, right? There's projects that are sort of like your small, reporting tool for X, Y, and Z, and you have the thing that actually powers our search engine, right? And so what tends to happen is for the ones that have less gravity, and essentially a very forward-looking team, they will just pick up, 11, 13 and play with it, right? Like, and say like, okay, you know what, we're comfortable, right? We don't have that much of a spider web of dependencies. Therefore, we can prove that this is fine, and they go out, right? For the ones that are sort of like more foundational to the business, what we see is that we are more careful, deep in our toes, and not necessarily, we are not late adopters in the sense that we don't wait until the last second. We did once and then we learn from it. We do a little bit earlier, at least not at the last call. So, but we do try to be very careful because of just we see like, and again, it's one of the sort of like the great benefit and the keyword here that you can bring so easy. You can bring a new big sort of like functionality into your project just by adding 10 lines of code in a Gradle dependency, right? So that's sort of like what we figure out. Sometimes, just because of the imprint that we have on dependencies, external dependencies, forces us to go to the slowest of those dependencies that we depend on.
Right. Sure. Okay.
So
all right.
One more thing on that before I think you're going to try to wrap up here.
Yes.
But I just want so it's interesting hearing, like you said, practitioners out there, people actually using stuff, because, it's hard for us to get, people, well, it's hard to get good information inside. And so it's really interesting to hear that stuff. My conjecture, and maybe you guys can tell me if I'm right or wrong on this, is that so I certainly think it's true that there is a lot of tendency for especially large organizations to gravitate to the LTS releases, and that makes perfect sense, right? Because support and whatnot and stability, and I think that the 8 to 11 transition is a special case because it has 9 in the middle, right. And a lot of people like to blame Jigsaw for that, but I think there were a lot of changes in 9 that were motivated by Jigsaw, but it's not Jigsaw itself. But there really were a lot of incompatibilities, like the
base 64
JavaX, moving the JavaX namespace, and
there's some rearranging stuff there with the so-called EE modules. There was the version string change that broke everything. What was the other thing? The classic one was the assumption. There was a lot of code out there that assumed that the system class loader was an instance of URL class loader, and so they just get that and cast it and make calls on it. And with the module system, that turned out to be that got changed to an instance of a different class, and then everything broke.
Wow.
So our hope. And, I don't know if this is true, but our hope is that once people get over the 8 to 11 transition, then the transition to later releases, and of course, the LTS coming up is 17, which will be next year. But even interim releases between the non-LTS releases will be much, much easier to switch back and forth between those, because there really are not as many changes of the same nature as went into 9. So. And I've been hearing some things that people say once you get to 11, upgrading to new releases is much easier. And but that's kind of what I want to hear. But that's just sort of anecdote. And so I think that's just wanted to throw that out there.
Mm-hmm. Yeah, cool. Thank you, Stuart. So one last question. We've heard a bunch of cool features, and there's others you didn't even get a chance to talk about here, Stuart. But one of the things that I think can reduce the gravity or the stickiness of these LTS releases is commercial pull, is a feature that maybe you can't actually prove it quantitatively, but you just look at it and you go, holy crap, that's just going to save a lot of time. That's going to be a big win for our organization. Are you guys seeing that kind of pull on any of these features that we've talked about, that kind of like, this is a game changer?
I don't know exactly. I think, in many ways, 8 was a special release because it was. So if you look at the history of Java, there was 5 and 6 were the last releases under Sun, and there were Sun was doing badly and was not able to staff the JDK development team adequately. As you know, Paul, probably you lived through some of that, as did I. And so after JDK 6, there wasn't that much going on. And so Oracle had to buy Sun, and Oracle delivered JDK 7, which after 5 years of development did not have that much stuff in it. And so JDK 8 was a killer release because, of course, it introduced lambdas, which are really, really big attractive features. So I think that's sort of a one-off, and I think it was necessary to kind of revitalize Java. But there aren't very many things like lambdas. And, records, I think, are very popular. And, but are they as much of a game changer as lambdas? I don't know. And so I think, I don't know if there's going to be any big features that really pull people forward quite as much as something like lambdas. Mm-hmm. But, there's a lot of stuff in there. There's ZGC I think became non-experimental in JDK 15. Yep. There's this pile of language features. There's I think this is one of these things that's sort of incremental development. ZGC gets a lot of attention, rightly so. I think it's a great piece of work. But it turns out that there's another team. It's part of the same GC team, but another handful of team members are working on G1. And, G1 has, it's been evolving for a long time, and it was experimental for many years. And there was a bunch of hoo-ha about, replacing, getting rid of CMS, so forth, and complaints about G1. But the fact is that team has steadily been working on, the G1 team has steadily been working and delivering, percent speed ups here, percent speed ups there, percent space reduction, releasing resources to the system, all kinds of stuff. And so over a succession of several releases, like from 8 to 17, you'll see huge speed ups in G1. And so I don't think it's like anybody's going to say, yes, JDK 17 has this killer feature in it like lambdas. And I think the next feature like that might be Valhalla or Loom. I'm not sure. They're in a race. I'm not sure which of those is going to be next. Mm-hmm. And I should say that we do not know. We do not have a schedule for when either of those features will ship. They're still being worked on actively, but we don't have a schedule.
I'll add a little bit of a footnote that one of the things that I will tell you that will move us is any feature that promise us to use less resources on a cloud environment. So be this ZGC or even an implementation of libraries using Valhalla that suddenly produces less garbage or become more efficient, or give us speed up in performance. Those will be things that will be like, okay, this is worth trying because it's actually saving us money, just to actually upgrade. So those are the things that I'm always looking at, because we working on a very like compute intensive part of our stack, and those I want to play with. So
awesome, great. Okay, I think we've gone on long enough, more than long enough, but great discussion. I'm pretty sure we could go on for another hour.
Oh yeah, easily.
But
yeah, well, maybe we should schedule that additional hour.
Do the follow up. Yeah,
that would be great.
Great. Yeah, it's really great. So thank you. Yeah, really good. Although I do have like a virtual drinks after, if anybody still wants to hang on and ask questions. I don't know if Stuart can still stay or anybody else, but I can still be here too if anybody has any questions. But it's been a great discussion. I think it's really good. And thank you so much for those of you who have stayed too. I think I still see about 17 people or so. So yeah. Thank you.
We held on. No, thank you, Stuart. Like everything, it's always fun. Super fun.
That's right. Thank you. Did we miss anybody's question? I think we have answered all of the question, right? Yeah. There's a bit of a delay. So yeah.
All right. Thanks, everyone.
All right. Well, good to see everybody virtually. It's nice to get together and have a chat like this.
Yes.
Sorry for taking half an hour with the initial presentation, but
No, it was great. Yeah,
It's good stuff.
the original presentation would have taken an hour and a half. So it's much more interesting to talk about this stuff and follow the topics than to just go one slide after another. So
Yes.
hope everybody in the audience, I hope you found it interesting. Thanks for attending.
Yeah, thank you. Everybody stay safe and healthy, and very, very cool. And maybe if we can find another time, we should do this again, like another panel discussion like this, maybe like in 2021. And so that would be great. Yeah. All right. So
Great.
Okay.
Thanks.
Bye.
Great to see you, Stuart.
All right.
Thanks for your time.
Thanks so
Okay.
much, Stuart. This was fun.
thank you. All right. So I'll end the broadcast now, I think. Yeah. Or if somebody wants to still hang on, have questions, you can type it in here. I'll just leave this on for like a minute or so. If nobody has any more questions, I'm going to end the broadcast. Okay. Anybody?
There was a question asked, is there any more JEPs planned into Project Amber?
That one.
Oh.
Oh.
I thought maybe that's what I answered. Yeah. This one.
I'm sure there are, because some of the stuff I know that it was hard to tell from my presentation, but there's some things in there. So the bits of pattern matching that are coming into preview now are only going to be an instance of. And so there's a whole series of features which will eventually manifest themselves as JEPs to add things to like the switch statements and switch expressions will get type matching. So you can switch on the class or the type. And then there's going to be some stuff to do pattern matching and deconstruction, like was what I showed. And that was speculative, but I think that's definitely in the plan. One of the things that enables that is, since records are transparent, the components are known to the language. So the language knows that X and Y are record components of point. And so you can do pattern matching on that. But then there's also a need to say, I want to have a regular class, not a record class. I want to have a regular class that also will provide deconstruction services. And just like you have a constructor, you should be able to write an ordinary class that will offer up its contents as a deconstructor. And notice I'm saying deconstructor, not destructor, which is a completely different concept. But the idea is that right now, the compromise with records is, in order for the language to do deconstruction, you have to be a record, because that way you declare as fixed set of components that's known to the language. That's what we mean by transparency. So the languages team has a bunch of speculative features about how to expose deconstructors in the language, and I have no idea what the syntax for that will look like, because essentially you want to call a method and have it return multiple values, and there's no way to do that in Java. So I mean, that's kind of what it is, right? So a constructor takes an arbitrary number of parameters and returns you a single object. Yep. So a deconstructor takes a single object and provides an arbitrary number of results, presumably which are the field components or whatever. And so I don't know what the syntax will look like, but that's the concept. And there's going to be continuing development in that area. So there's a whole bunch of stuff in the pipeline for Amber. So, and I'm sure there will be some additional JEPs coming down coming through the pipe.
Perfect.
Okay.
All right.
All right.
Okay. All right. I think no more questions. Then we're going to end this broadcast. And thank you again for everybody's participation tonight, and send us your feedback and good ones especially. So thank you.
Please rate this podcast 5 stars.
Yep, that's right. All right then.